Bismillahirrahmanirrahim. Today we will start testing of hypothesis for population variance sigma square or standard deviation sigma. Before this we have done testing of hypothesis for population mean when sigma is known and sigma is unknown. We have used two tests, t test and z test for mean. Same as the mean, there are 6 steps. The following steps are used in testing of hypothesis for population variance sigma square or standard deviation sigma. You know that if you take the square root of the variance is equal to standard deviation or sigma. Same as if sigma is given, you can take square for variance sigma square. First step, null hypothesis. For mean we use the notation mu is equal to mu naught. For variance we will use the notation sigma square is equal to sigma naught square. This sigma naught square is the value of sigma square. Alternate hypothesis is a parallel setup of the null hypothesis. If this is equal to, alternate will be not equal to. If null is less than equal to, alternate will be more than. If null is more than equal to, alternate will be less than. Same as the mean. Third step, level of significance alpha. Fourth step, test statistics. We will use chi-square test. This is the notation of the chi-square. This complete term represent the one notation chi-square. Read as chi-square. This read as chi-square, not chi-square. Is equal to n minus 1 s square upon sigma naught square. N is the sample size, s square sample variance, sigma square is the population variance. From this you will obtain the chi-square calculated value, observed result. Fifth step, critical region or rejected region. Same as the mean, t test, z test. We have 3 choices, depend on the notation or symbol of the alternate hypothesis. For not equal to, we divide the alpha by 2, but in this chi-square used for variance. Variance is always positive, cannot be negative, so there is no negative sign. In t test and z test the values are same but sign is different. Left hand side is negative, right hand side is positive. But in chi-square test used for variance. Variance is always positive, both values are positive, but values will be different. Because this value, this stable value will be obtained with the help of 1 minus alpha upon 2, this value using the alpha upon 2. So alpha is suppose 5%, so this alpha upon 2 will be 2.5%, 0.025, subtract from 1 you will obtain 0.975. So this value will be 0.975 and this will be 0.025. So both are different, table value will be different. This is the sketch diagram. The graph of the chi-square test is the skewed graph. Right tail is long, you have done skewness under the heading of the frequency distribution table. So right tail is long is the positively skewed, is also called right tail test. The shaded area, colored area represent the rejected region or critical region. This is space, blank space, white area represent the acceptance region, represented by 1 minus alpha. And second option depend on the less than, third option more than. So number second, this is not first, this is second. Less than, alternate is less than 1 minus alpha, there is no alpha upon 2. For right hand side more than, this will be alpha, there is no alpha upon 2. So this left hand side shaded area 1 minus alpha comma mu, right hand side shaded area represent the rejected region or critical region when alternate is greater than. 6th step, same as the mean. If the calculated value lies in the critical region, we reject the null hypothesis, otherwise accept the null hypothesis. So there are 6 steps. Now we will solve numerical. First question, a training instructor claim indicate null hypothesis. That his training method are so efficient that the variance, claim is about variance of the time required by his trainees to complete a job does not exceed 30 seconds. Claim indicate null hypothesis. Null hypothesis for variance indicate we will use the chi-square test. Does not exceed means less than equal to, notation of the null hypothesis will be less than equal to 30 seconds. So null hypothesis variance does not exceed less than equal to 30 seconds. Alternate is a parallel setup, this will be more than. If a random sample n is the 21, sample size represented by n 21, trainee yielded a variance is the sample variance s square 33 seconds. Do you think this evidence supported the instructor's claim? Use 5% level of significance. Alpha is the 5%. So sigma square and s square is given. First we will and after this we will find the table value for critical region. Substitute these values and s square, sigma square, 30, 21, 33 in this formula, you will obtain 22. So this is the calculated value, observed result of the chi-square test. Now we will find the critical region. Alternate hypothesis is greater than, so we will select this option, greater than chi-square alpha mu. Alpha 0.05, there is no divided by 2, degree of freedom 21, minus 1 20, n minus 1, same as the t-test, degree of freedom is n minus 1 20. So how we find this table or this value? We will use chi-square table given on page number 6 and in your book. This is the chi-square table. Alpha is here 0.05, degree of freedom is 20, the corresponding value is 31.410. So we will write this value, this table value, expected result with 5% area in diagram 31.41, and this calculated value is less than 31, lies in the acceptance region. So we will accept the null hypothesis. Accept the null hypothesis means this claim is true. We support the instructor's claim. The calculated value lies in the acceptance region and conclude that the instructor claims is correct, because the question is instructor claim is correct or wrong, or we support the instructor's claim. Do you think this evidence support the instructor's claim or not? So we support the instructor's claim or accept the null hypothesis or accept the instructor's claim. The time required to complete a job does not exceed 30 seconds. Okay. Now next topic, for same condition, confidence interval. Confidence interval for population variance sigma square or standard deviation sigma. If s square is the variance of random sample of size n from normal population, a 1 minus alpha, this 100% into 100% confidence interval, this is the part of the 100%. For this we subtract from 1 minus alpha. 100% confidence interval for sigma square is given by, this is the formula of the confidence interval for population variance sigma square. So n sample size, s square variance, we will find for this value from table with the help of alpha upon 2 and 1 minus alpha upon 2 and degree of freedom, and then we will obtain the lower acceptable value and upper acceptable value for variance. The concept is same as the mean. So we find with the help of confidence interval the lower and upper value of the variance. Now we will solve question. The weights of 10 boxes, sample size 10, of orange juice selected at random from cans packed by a company are 15.4, 16.1 and so on, 15.7. There are 10 observations you can find with the help of calculator or formula, but you have to use in exam calculator for saving the time. So you will obtain standard deviation and variance from calculator direct 0.149, and is the 10, degree of freedom will be n minus 1 9. So n is 10, s square is this 0.149. Now first we will find the table value, two table values. Compute a 95% confidence interval means 1 minus alpha is 95% or 0.95. So alpha will be equal to 5%. Okay. For this value, divide by alpha by 2, divide the alpha by 2 will be 0.025 with degree of freedom 9, and 1 minus 0.025 will be 0.975 with degree of freedom 9. So we will find first from table of the chi-square test. Degree of freedom is 9, alpha is 0.025. Alpha is 0.025, degree of freedom is the 9. The value is 19.023. 19.023. Second value, with the help of 0.975 with degree of freedom 9, and this 0.975. This blue line indicate for 0.975 2.70. 2.70. Substitute these values in this formula and 10 minus 1 9 s square, table value 19.02 2.70. Simplify this, you will obtain the lower value and upper value of the variance. Same as the mean, write the conclusion. We are 95% confident. For question is find the confidence interval. So we are 95% confident that the variance, this is the variance of all canes. All canes means for a population variance represent the all canes of orange juice will be lies between this lower value and upper value 0.07 and 0.50, same as the mean. Okay, this is the table I have already explained. Now homework for testing of hypothesis and confidence interval for sigma square or variance. So for variance, if you use same formula, and for standard deviation, if you take square root of this value 0.07 and 0.50 will be sigma. So if you take square root both sides, this will be sigma, and this value will be value represent the confidence interval for standard deviation. Formula is same. So homework for both sigma square and sigma, chapter number 10, page number 323, question number 1, 2 and 5 for testing of hypothesis and confidence interval, chapter number 9, page number 282, question number 3, 6 and 7. Okay, Allah Hafiz. Next time we will start new topic.